Good morning. Today's class we'll see about specific heat. Right now, I know some of or a few of my students they struggle with this calculation or understanding this concept. I'll try my best to explain it as simple as possible. Let's see. Now, see if you have a substance and if you want to just any random substance. Say I have got a glass full of water and you want to increase the temperature by 1 degree Celsius. Right, I've got water and another person has got in a jug he has got the same liquid but a different amount. He or she wants to increase the temperature by 1 degree Celsius. All right, two situations here. So you have got a small amount of liquid, say in a cup, and there is a big jar or whatever. So you have that also to be, that's full with water, and I have little amount of water here. Both I want to increase the temperature by 1 degree Celsius. Now should I be supplying the same amount of heat to both? Obviously not, right? This will require more amount of heat energy. Now say earlier I said both are same liquid. Imagine this to be water and now here I've taken some random juice. Okay, but now say I have a similar mug with the same amount of liquid. Now here the amount of liquid is the same, but then the liquids are different. Will they require the same amount of heat to increase the temperature by 1 degree Celsius? No, right? Now to each substance will have a different amount of heat energy to increase its temperature by 1 degree Celsius. Now to have a comparison, which one requires more, which one requires less, or by knowing that you can calculate how much energy should be supplied to a bulk of the same material. Those kind of calculations are all be easy for industrial purposes or for daily lives and so on, right? So to have this standard value or this amount of heat energy required to raise the temperature of a substance by 1 degree Celsius is called thermal capacity. I did not use the word specific, it's called thermal capacity. So this gives you what? The energy required to raise the temperature by 1 degree Celsius. So what's the difference between thermal capacity and specific heat capacity? Specific heat capacity is for 1 kg of a substance. All right, if I take water, if it is 1 kg of a substance and if I want to increase the temperature by 1 degree Celsius, how much energy should I supply? That value is called specific heat capacity, which is roughly about 4,200 joules of energy should be supplied to 1 kg of water to increase its temperature by 1 degree Celsius. If you want to have a comparison, if you take aluminium, it requires 1 kg, 1 degree Celsius, it requires only 900 joules of energy. So do you see the difference? Water requires 4,200 joules of energy and aluminium only requires 900 joules of energy. So each substance will have likewise different values for these temperatures to rise. But then what have you kept as constant? The mass of the substance is 1 kg. The temperature rise is 1 degree Celsius. That amount of energy is what we are actually comparing. That is specific heat capacity. Alright, now the definition, I'll come to it. Now how does it differ from specific latent heat? Now the latent, actually the meaning of this latent term itself is hidden heat, right? Now what is that? If I take say a block of few ice cubes, I just leave it outside and I'm using a thermometer to test the temperature. Now, if the ice has to melt to liquid, do we have to supply energy? We may not be heating it, but when you keep it outside, it is absorbing the heat from the surrounding, which means the temperature of the ice cube must increase, right? But then you will notice the liquid that is melted initially, that liquid also will be at 0 degrees Celsius. All right, there's one example, keep that in mind. Another example, you are boiling water, you're supplying heat. Okay, the water, it reaches boiling point, it starts to convert from liquid to gas. You're keeping a thermometer and checking. The 100 degrees Celsius will remain as 100 degrees only, though we are constantly supplying the heat energy. I repeat, we are continuously supplying heat energy. It's not going to the atmosphere alone. It is absorbed by the liquid. So what do we expect? The temperature of the liquid to rise, but it doesn't happen. It doesn't rise beyond 100 degrees Celsius. It stays at 100 degrees Celsius until all the water is evaporated. Alright, so here also it is absorbing heat energy, but the temperature does not increase initially when the change is happening from solid to liquid. It remains as 0 degrees Celsius. Here also it remains as 100 degrees Celsius. So the question is, so what is happening to this heat energy that is applied? It is absorbed by the molecules, but it is not showing any rise in the temperature. So we call that as hidden heat energy. What is it used for? The answer is here. Of course, there have been lots of investigations done, and this is the conclusion from those analysis. These molecules which are in the solid state, we all know they are tightly packed and they have got strong force of attraction, right? To break them apart and to free them into a liquid, you need to supply some energy, right? So the molecules pick up that energy and they use that energy to break these force of attraction, or we say break the bonds between the other molecules and free themselves into a liquid. That's the reason we are not seeing, because the average kinetic energy of those molecules do not increase. But we have seen in a previous video, average kinetic energy is what determines the temperature of the substance. Since the kinetic energy does not differ or change, you will not notice any change in the temperature. Getting it? So here, when will this be observed? Only when change of state is happening, either from solid to liquid or from liquid to gas. You notice that the temperature does not change, though it is absorbing heat energy. So what is that heat energy used for? It is used to overcome the forces of attraction between the other molecules and convert themselves from one state to another. That heat energy is called latent heat. Alright, so now here again, will this be the same amount of energy required for ice to change it to water, like solid wax to liquid wax, or copper to molten copper, and so on? No, each substance will have different amount of heat energy required for 1 kg of substance. That is called specific latent heat. Okay, so in general, if you want to describe specific latent heat, will be what? Specific latent heat of energy will be the heat energy, again same, heat energy required to change one state of a substance to another. What's a clause here? Without any change in temperature. Clear? Without any change in temperature. Now, if it is from solid to liquid, we call that as fusion. Specific latent heat of fusion is from solid to liquid. If the question is specific, what is the definition for specific latent heat of fusion? How should you frame? The energy required to change 1 kg of a substance from solid to liquid without any change in temperature. Similarly, this will be specific latent heat of vaporization. You just have to change those two terms from liquid to gas. Have you understood the differences in terms of definitions, and why here, how is this different from latent heat? Specific heat capacity is change in temperatures is there by 1 degree Celsius, alright, for 1 kg of substance. Here it is 1 kg of substance, no change in temperature but change in state. I hope the definitions are clear. I'll repeat. You can pause and try to recollect and then compare your definitions. Specific latent heat of fusion is the energy required for 1 kg of a substance to change from solid to liquid. Evaporation, change from liquid to gas. Specific heat capacity is the amount of heat energy required to raise 1 kg of a substance by 1 degree Celsius, or by 1 Kelvin also you can write. Alright? Clear? Now, specific heat capacity and thermal capacity. Thermal capacity is like, if you take any amount of substance, how much energy is required to increase its temperature by 1 degree Celsius. Clear? See you in another video with a few examples, using calculations. There are like experiments to find out specific heat capacity and also latent heat that you must know, and some calculations as well. See you in another video. Bye.